Hello and welcome to T3 Alliance and your weekly show. I'm Adam and we're here in Hilo and it's a little bit rainy out today, but today we're gonna take you into a little bit of utilizing Scratch and how to do basic programming. We're getting started on lesson number 5. Now I'm just jumping back over here to my screen from where we were last week. We had zoomed in and dealt with building the Raspberry Pi kit and computers, Raspberry Pi, and the Internet of Things. I realized that, gosh, I didn't make that link live, so I'll update that in just a little bit. It's got our show from last week where we talk about what are some different ways that we can use Raspberry Pis in our community. But today we're going to delve into both Scratch and basic programming and Node-RED and programming the GPIO pins, because so you know a little of my background. I was a makery teacher, a makerspace teacher, and I had 20 students in middle school who are using Raspberry Pis, and for me Scratch was a really powerful tool, and we'll jump into it a little bit. We'll give you guys a little bit of an introduction. I'll show you what to do, but as I've been speaking with teachers out there who are going through this curriculum, some people find that Scratch is, well, it's something that kids have been doing for a while. So if that's your scenario, then Scratch is one of those things you can skip and move through. But we can learn some big idea things about that. And then today I do have my computer set up over here, and we are ready to actually plug this thing in. If your students are where I think they are, they're excited, they're ready to go, and ready to jump into what can I do with this thing. I've got it, I've built it, I plugged it all in. They spent a few days, or they spent just a minute if they plugged it in, like noticing that it looks a lot like a regular computer. But now's where we go back to that idea that it's not just a regular computer, it's a computer with, there we go, it's a computer with some power behind it. So I'll share this presentation with you and come back to a kind of a refresher here. There's basic inputs and outputs on the Pi. Remember last week we already talked about what makes a computer, but when we think about what do you do with a computer, the big power that comes from a computer is the ability to give it sets of instructions so that it can do things that once took a lot of paper and pencil or logic and there's a number of computer programs that come built into your Raspberry Pi, things like Scratch, C++, JavaScript, Node-RED, and these are all different ways of giving a computer a set of instructions. I like to break it into two different categories. One is visual programming languages, and the other is text-based programming languages. And for a student, they can know that both of them get the job done. One of them has a little bit of something at the end of it which helps it understand the difference, but they both have the same purpose of explaining what's this step, the next step. But concepts are pretty universal, whether or not you're using it in a text-based programming language or if you're using it in a visual-based programming language. And there are things like variables, things like loops, conditional statements, and if-then statement. These are things that computers are very good at doing. So we, in this program, use visual programming first, and then later on we can recognize that students can jump into using text-based programming languages, things like Python, Java, and other things. I will recognize that when we got started with T3 Alliance, we saw Minecraft and said, oh my gosh, Minecraft and Python, you can do both of them at the same time, and it is possible to teach a student how to use Python by playing with Minecraft, but there are possibilities for errors that can come up that allow a student to not feel successful. So our big one that we focus on here is there's a special computer program called Node-RED that we'll spend the majority of our time on, and it's all about Internet of Things. It's been built by some people who said, let's make this as easy as possible so that we can start building stuff utilizing the power of the Pi, the power of some of the pins that come off of it, and we can spend time playing. But when as a former teacher, I have to recognize that Scratch is awesome, and I'm putting this one in here so that in the event that you know your students and you know that they're coming in as brand new beginners, then you could spend some time letting them play with Scratch on their computer. You could say, I want you to make a Scratch program, and I want you to have a sprite that does things. What you can see here, this is what a basic Scratch stage looks like, and you can open up Scratch by clicking on Programs on your computer and go into Scratch, and you'll see that there's a little sprite, otherwise known as, you know, the thing that you're controlling. This sprite has like a set of motion commands that are instructions for how it moves across this stage here. And if you look here and click on motion, you'll see that there's a bunch of commands, 10 steps, 10 pixel spaces, 10 moves that can be put in sequence. And a sequence of steps is essentially the simplest kind of computer program. So as just a beginning place, coming in here, you can watch as you put a set of instructions in and have a cat do something. So playing around with it at first is like stage 1. Oh, let's watch our cat move. Okay, and then stage 2 might be, all right, let's make this cat dance. And one of the things I like about Scratch is that in the event that you're a busy teacher with a lot of students who are raising their hand asking for help, this one has built-in tutorials. Scratch exists both online, so that you could open up a computer and go to any browser and just type in Scratch, and a student could either log in or just play along as a beginning user, and they could say, hey, let's do the getting started from Scratch tutorial, or let's animate your name, or let's make something fly. Any one of these things will give you a step-by-step tutorial that is very clear and kind of teach you each of the components that go along with it. But when you work with a group of students, the basics are understand your work area, that this is the area that you're working in, that there's a palette over here, and that you write scripts that go out here. These scripts are instructions to the thing there, or to the sprite. There's some concepts that come along, and these concepts are concepts that will translate over into other areas, into other programming languages. So the first concept of sequence. A sequence is a program. When you create a program, you need to think systematically about the order of steps. First do this, then do this, then do this, and then whatever. A loop or an iteration is if you said, hey, do this forever. A computer is very good at doing something over and over again until something, a repeating set of instructions. So kids very quickly find that if they put a sound in there and repeat it over and over again, it's kind of fun. Conditional statements, an if else or if then statement. If this is here, then do this. There are tutorials in here where you can learn to make games, make little activities. And what I come back to is that if you just set aside a time and say, everybody, you need to play, you'll be able to know that your kids who have some experience with this or your kids who don't have experience with this can both be growing. My brother's a computer guy, and he works on, website stuff all day. He has a lot of knowledge on this, but when he jumped in and said, okay, I'm going to play for half an hour, there were some really cool stuff, and he was having a lot of fun as he messed around with this. So the ideas of variables, the ideas of lists. And what I like is that with Scratch, there are always opportunities to find that it only works when something is clicked from one place to another place. Each one of these little indentations, they represent something that will either work or it won't work. And if it doesn't have the right indentation, then it won't work. And in a similar fashion, when we translate over to stuff with text-based programming, if you miss a space, if you miss like an enter or you misspell a word, it won't work in the same fashion. But it's easier for people to see when it's a visual programming language. Threads are a kind of cool idea that, hey, a thread means that two things can be running on the same program at the same time. So these are some things that you can emphasize. I wouldn't spend too much time emphasizing it because kids want to learn and want to do something. They don't really care as much what is the fancy term that goes with this. This is more something that adults love. They love to know that, oh, I'm doing a random number generator. Well, a kid just wants to know what's happening here, and is my game working? So when I go through this with students, I usually spend some time playing, and then I end with a project that comes off of the Raspberry Pi Foundation. And it's the raspberrypi.org program called Astronaut Reaction Times. And I'll have that link in there for you. I think I have it right here. And this is an opportunity to share with you what is raspberrypi.org's website. The Raspberry Pi Foundation has a ton of resources that are helpful. And a computer with Scratch 1.4, it could be done on a Pi or it could be done on a computer, but it just comes native on your Pi. And they'll set the scenario up. Oh my gosh, there's micrometeoroids that hurtle towards people out in space, and we have to figure out what the astronaut reaction time is. So as you go through here, you learn that there's a handful of things that we need to constrain, we need to build, we need to paint our own background, and in the end, you will make an astronaut where if they say go or you say go, it will time how long it takes for you to hit the space bar on your computer. Remember, a space bar is just an input, and find out that your reaction time is this far, and the ISS, the International Space Station, travels 6 kilometers in this many seconds. So again, this is a game. It can be looked at in such a way that people are excited about playing it. The kids can say, holy cow, this was awesome. Look, I just did it. I just wrote my own program. Celebrate that moment, and then say, okay, are you ready to get on to the next thing? Because all you've done is use a computer program that's built in here. We haven't really unpacked the power of the Pi yet, but you know, I've had students learn to make games with each other where one student hits the space bar and the other student hits the enter key, and they race who's faster at hitting the start stop thing. It's a simple game, but it gets the idea across. So in that sense, that's all I'm going to say about Scratch. If you want to use it, go for it. The link is down there for that website. I love it. I love to talk about this strand over time, but for the most part, just know that it's there. Now I'm going to switch to our next video, and I'm going to pause this one, and I'm going to start again, just so it makes 2 distinct YouTube videos that I'll put into my next one. And the next one is all about, let's learn to use our GPIO pins, these little things that come on our Pi right here, these little guys right here. We're going to learn to talk about these things and use Node-RED for the first time. So that's it for Scratch. I'll be right back on, and we'll talk about Node-RED. So bye-bye. Hello, everybody. This is Adam, and we're here today talking about the next topic on our agenda, or the next topic in our sequence of 20 lessons, called Node-RED and programming your GPIO pins. So just for quick reference, which one is this? Right here, if I remind us where we are, here's our lesson sequence. And we've talked about computers, Raspberry Pi, Scratch, and basic programming. And again, Scratch is one of those ones that we have fun with. But now we are ready to jump in and say, let's do some programming with the GPIO pins and understand how it can be used to control the pins on the Raspberry Pi. So we're going to explore a program called Node-RED, and then we're going to plug in our pins and let's actually do some cool stuff. So here we go. So just for your reference, the format I'm going to use here, we're going to teach about the topic, and then we're going to jump in and get our hands into it as we go through it. So I'll jump back here and dun, da, 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 programming Node-RED and GPIO pins. And again, I will have this slideshow ready for you. Here's the same thing, review, inputs, outputs. That's always part of the Pi. We know that there's text-based programming languages, visual-based programming languages, that's all there. But what is this thing called Node-RED? It's another programming language that, or it's a visual programming language which takes some underlying text-based programming languages and makes it easy to move it around. So this is one way in which you can see, here's the sensors in my house, that the temperature's saying it's this high, the humidity says it's this high. It can make me a gauge as an output very easily. But on the input, what it means is that if I have some device that's sending information, then just like Scratch was before, I can have that send to one place, send to another place, send to another place, and it can appear in whatever form I want it to appear in. So it can make me a gauge for humidity and temperature, or it can make me a chart for something else when it comes out. So it's got a lot of power. I like to think of it in terms of, hey, it's not that far. So if a student is kind of familiar with Scratch, they know that, oh, in Scratch I've got, you know, control bases, I have motion commands, I have that kind of thing. Here I have nodes that are responsible for different things. The language is a little more complicated, but it's very similar. In order to start Node-RED, you're going to do something a little different. You're going to go into the programming tab on your Pi, and you'll push the Node-RED button. And once you push that, you'll get a little box that'll open up, and basically it will start the underlying programming that happens behind the graphical user interface, and it'll say run Node-RED. You don't access it that way. You don't do much in Node-RED over here. Now what you do is you open up a browser, and if you open up a browser, we've made it so that Node-RED is a browser that is just saved in each one of your hot buttons, or whatever we call it. But if we open up the browser by clicking on this little thing and click on that, it should open right up into a browser, and you'll notice that there's an address on there that's 127.0.0.1:1880. And that 1880 is the name of looking on the server for this actual computer. So it's looking within itself and saying, where can I find it? Once you're there, now it's time to get like a little aware of what are the different areas of this thing. So there's the input nodes. These are what they're called, the nodes. They're the things you drag over. So just like Scratch, you click an inject node, you click a catch node, a MQTT, and we'll describe what that means later, and you put it into this little area. In Scratch it was the stage, but for us it's called a flow. And then there's info about the node, so if you click it, then you'll get some info. And there's what's called a debug node. And the debug is where if some information is spit out as part of the flow, then it comes out there, or if something error is not working, then it comes out in that spot. So we'll practice this in a little bit, but still that's where it goes. The deploy is the button kind of like the green flag on the Scratch thing. It's the, hey, let's make this thing actually work, or save your changes. And what I love about Node-RED is, in the event that you built this amazing flow and, oh no, somebody tripped over the computer cord next to your desk, it got unplugged, it saves everything all the time. So as long as you've hit deploy pretty recently, it will save whatever you've got, and you don't have to worry about it. You will have some other features in order to turn it off. Here's some examples of what flows might look like in Node-RED. So the first one is a Twitter input. So there's a little tweet, and it says, hey, if you see something that says #LED come in my way, then trigger something that turns on a pin, and that pin number 12 and have it go to an output. And if everything works, we get on our phone and send a tweet, go to trigger node, and it comes to here, then our Pi should turn on a light bulb. And that's pretty cool. I just turned on the light bulb with Twitter. Over here, here's a situation where it says, hey, if the weather now, and that's getting the weather from somewhere out on the internet, from somebody who has shared the weather data packets, the weather now, if the temperature is below or above 15 degrees Celsius or Fahrenheit, whatever it is, then turn on my Fitbit activities and tell me, oh, my summary steps are less than 1,000. Say, send me an email that says, you lazy guy, or you know, should really get out and do some exercise because the weather's nice today. Can you imagine? Do you see what that just gave you the ability to do? You could send yourself an email when the weather's nice outside to say, you're not exercising, go do it. This is powerful. And hopefully kids will see how powerful this is in a little bit. There's three main types of nodes. The first is the inject node. Then there's a debug node. And then there's what's called a function node. And I like to think of the inject as like your input. It's like, you know, all of these over here are ones where data comes in. It's just like my keyboard is a physical input. The inject node is a digital input. The debug node is an output node. It is an example of tell me what came out here. So if that was, you know, like a feature, then it would tell us something happened. The function node is let's take some information and let's do something with it and spit it back out. So, you know, a function might be I get a signal and now I'm going to delay it for a little bit and then I'll send it out. And then, you know, a switch node might be, hey, it comes in. If it's here or here, then do something with it. If I remind us, we did just a little bit ago a switch node and we said, if the temperature is greater than 15 degrees, then do something. If it's lower than something else, then it'll do something different, obviously. But that's kind of how a function node works. A function is, I'm going to make a change to it. And then I love just pointing out that and kids will see this right away, that email and Twitter are both a part of this. So that those are absolutely inputs and they're absolutely outputs. So notice that if something is on this side, it's definitely an input. If something is on this side, it's definitely an output. So if you drug over this little node, this would mean receive that email and then do something. This one would mean you received some information like, you know, the weather's nice outside and now do something. And the same thing goes with Twitter. So pretty cool. All right, so here we go. This is building a test flow and adding a comment. So in just a second, we're going to open up and we'll go through this thing, but bear with me for a second. So a comment is something that we often do for any sort of a program that we're writing, just to kind of give some information about the program that we're doing. So you could open up a comment and call it, this is my first node red flow. And if all you did was say, I'm going to take a timestamp and I'm going to drag another one in called a debug, which would come out as a message payload. If I drag those things across there and I push this little, and I have to deploy it, so don't forget that there's a little deploy there, and I push this little button right there, and you can't see it because my face is in there. It could go like that. There we go. But if you push that little button, then it'll come across and you'll get the answer that says 1437, all this kind of stuff. What is that actually boiled down to? That's the number of seconds since some time. I don't know. Somebody would remember what that number of seconds is, but I don't remember what it is. You can adjust what your payload is, so you can adjust it to a timestamp or a string, and you can change it to, if this timestamp comes through, then the message payload could be, hey, here's my message that we want to come across with. So again, we'll try this out in just a second. We'll play with it so that you guys understand what it is. And then the next thing I want to point out is that there is a really cool feature of how do I save my work, or can I share it with somebody? And the answer is by all means, yes, you can share this with somebody. So if you click on the import or export, then you get like you get this long string of data, and you can just copy that whole thing and you can paste it into another browser, or you can paste it into someone else, or you can send it to someone in a message and you can copy and paste that. So we'll try that in just a minute. That's one of the things kids will try. And then here's what we really are excited to get to. This is the thing that makes a Raspberry Pi so incredibly powerful. It's awesome that it's a computer and it's only $35 and it's got a, you know, an Ethernet port, 4 USB ports, all this kind of stuff. But what really makes it different than a laptop in their computer lab, that makes it different than anything else, is the fact that now each one of these little pins here can send a signal or receive a signal from you know, the processor here. So I like to Chester always has includes a little nameplate with his Raspberry Pis. This nameplate that we're seeing right here is not the one that he does, but it's close enough so we can review it together as we go through. The little pin up here at the very top, this one right there, is always 3.3 volts. This one right here is always 5.5 volts and 5 volts. 5 volts. These other ones with these names, GP2, GP3, GP4, ground, GND, you can imagine what that stands for. It stands for ground. You know, GP14 as we go down. And then there's some weird ones in here that like say IDSC, some other ones like this. Don't worry about the weird ones as much, but just know that 5 volt, 3.3 volt, this is almost like a basic battery. It means, oh yeah, here's what the EasyBotix one looks like. It says USB port goes on this side, and there must be some pin that goes with it. But what you can know is that anything connected to these pins will always receive 5 volts of power. Anything connected to the 3.3 volt pin will always receive that much power. So if we're going to try to emulate what a plain old normal battery looks like, a battery like this is, I think it's 1.5 volts. So if you put two 1.5 volts together, then you can light an LED bulb. And if you light an LED bulb with this much electricity, with this much current moving through here, you'll oftentimes burn the bulb out. So we include a resistor. In our newest kits, we've been sending out Raspberry Pi LED bulbs that don't need a resistor. It's got a built-in resistor as it goes. But you can see the basic premise here is that if you were to connect up two batteries to two sides of something, you would be able to send that electricity, and in the same capacity, you would be able to send something through there. A caution to you on basic circuits is if a student hooks up the 3.3 volt pin directly to the ground, or a 5 volt pin directly to the ground, the Pi should turn off and just say, oh, you know, I'm restarting, but you could also fry the Pi because you're basically taking the electricity right back into the thing and it's not ready for that much. So that's one caution to watch out for with your students. But yeah, here's that slide I was telling you about. In our scenario, these are the kind of LGB boards that we send, but the resistor right here is built into here, so you don't have to worry about that there. But this R, G, B, and ground, that means if the R is plugged into one of these, if the G is plugged into one of these, if the B is plugged into one of these, and the other one is plugged into ground, then that color will come up. So we should try this, just simply like see if this will work. So I'm going to pause right now and jump over to my, well, no, I'm gonna let you pause the video here. Know that we could do this. I'm going to keep going, and then we'll do all of that together at one point. But this is fun to see. And know that just like we said right here, if you hook up the 3.3 volt to the ground, this 3.3 volt to the R, then it'll come out red. If you hook up that 3.3 volt to the ground, it'll come out green. If you hook up that 3.3 volt to the blue here, it'll come out blue. And in the same capacity, you know, you can connect that up into a lot of different ones. So now it says, let's set up an LED light. Let's go ahead and do that. And I think this is where I'll point you into opening up the tutorial that we've got in there for the RPi Node Red RGB LED tutorial here. And we've got our parts, and then here's an instruction that says, all right, you're going to put the ground right here. You're going to put the three components right here, and it's simply 3 pins that are part of this flow. So the 13, the 19, and the 26. These 3 pins being part of the flow means that's what you're going to have to write into the program. And then we're going to set up a flow that'll look something like this. And again, I'll jump in and do it along with you here in just a minute. But for now, know that each one of these things is going to say on and off. These are inject nodes. We're sending this signal over, and right here, if we open up one of these red buttons, green buttons, or blue buttons, we'll find out that the output node for this one is pin 37, right? The pin 37, we call it blue, and its properties are set. So once that one's there, this one, pin 35, we call it green, and its properties are set. And this one, pin 33, we call it red, and we set its pins. So that's what we'll do. As long as we click on the inject nodes and we say that, okay, if your payload is between 0 and 9, and we know that when we think of a computer, we think of 1 is on and 0 is off. So we'll make the on one have a 1 on it and the off one have a 0. So remember, we're going back these 2 steps. If we double click on any one of these things, the off and on, then we can change it so that the on button is a 1 and the off button is a 0. Okay, and then we hit deploy, and then boom, we should be ready to make it go. Okay, so if we wanted to add a button into there, we would do something else to it. But first, I'm going to go ahead and add and do this along with you guys right here, and then we'll switch out and add some buzzers in here, and you can start playing around with some of these other fun things of Node Red, receive a thing, and that kind of thing. So let me jump over to my big screen, and there it is. All right, and I look right here and I see, oh my gosh, I've got Node Red running. I'm about to show you one of the coolest things that I like about Node Red. If I click on this guy on web browser, first let me make sure I'm on Wi-Fi here. Ethernet link is down. Am I connected to Wi-Fi? Yep, I think I am. I'll click on Node Red. Okay, looks like I'm on Node Red and everything is there. My screen looks really, really compact right here. So that's kind of annoying to me. And there's one way that I know I can go through and just check my settings and restore them to default. But what I'm also going to show you here is another fun way that I can identify what is my IP address that's associated with this thing. It says WLAN 0 is not, Ethernet is down. Huh. Okay. If I knew my IP address, then I could pull this up and we could copy it off of here, and then I could drive this on my computer. but my IP address isn't up right now, so I'm gonna, I'll tell you what we're gonna do. We're going to come back and say that hang tight, or I'm going to end this show for today right now, and I'm going to come back and add an addendum onto this one where we'll demonstrate what's happening here, because for some reason my Wi-Fi isn't working right now, and we'll make it go. But if I review here for everybody, our goals for today were to get an understanding of what Node Red is, to play around a little bit with some of its features, understand how we can do basic programming with it, and allow ourselves to start using the pins that are associated with the Raspberry Pi. And again, I will make sure everything's working, and then I'll jump back on. But just so I don't leave you guys standing there waiting for it to get going, then we'll stop this and we'll start back up again later. All right, everybody, thank you very much for tuning in, and we'll catch you guys later.